Hello everyone, hope all of you are doing great. And in today's video, we are going to discuss everything that is related to percentages, to rounding, lower and upper limits. So the first thing that we're going to start with over here is the percentage rule, which applies to all six cases. What are the six cases? In case they request from you the percentage increase, percentage decrease, the percentage change, which is the same as the percentage increase or decrease, the percentage profit, and the interest rate or the percentage loss. All of the six cases follow the same rule, which is absolute change. What is the meaning of absolute? It means it is positive change, which means that the positive difference. The positive what? Difference. So here you're going to find the change between the old value and the new value, which means minusing them. The answer must be written over there as a positive value. Over old, then you multiply by 100. And remember, always, if you want to find the percentage, you must have a fraction to find the percentage of anything. You must have a fraction, then you multiply by 100. This will turn it into a percentage. So let's continue over here. A technology company recorded 48,000 app downloads in March and 60,000 app downloads in April. After launching a new advertising campaign, calculate the percentage change in the number of app downloads from March to April. All right, so the first thing that you're supposed to do over here is writing the rule, which is absolute change over old or original value multiplied by 100. Because they wanted the percentage, I must multiply by 100. So absolute change is what? The difference between 48,000 and 60,000 minus them, but the answer must be positive. So 60,000 minus 48,000 is 12,000. And here is the absolute change over old value. Where is the old value? It is the 48,000. Okay, that's in March. Then the next one is in April. So it's 48,000. This is the old value. Multiply by 100. Simplify, then multiply by with these three zeros. Now we've got 12 over 48. Divided by 12 is 1. Divided by 12 is 4. So I got 1/4 multiplied by 100. You want to say 100 over 4? Fine. You want to simplify the 100 with the 4? Fine. You're going to find that it is 25%. So launching and calculating the percentage change in the number of app downloads from March to April, it is 25%. Here they're requesting from you to find 37% of a number or to find any percentage of any number. This is something that you learned in year 6 actually. How can we do it? You just simply multiply 37 by 83. And the answer, you divide it by 100. So doing this, 37 multiplied by 83, 3 times 7 is 21, carry up the 2, 3 times 3 is 9, and 2 is 11. Put a 0. 8 times 7 is 56, carry up the 5, 8 times 3 is 24, 24 and 5 is 29. Add them up, it is 1, 7, then 10, it's 3. 3,071. Yeah, but you did not divide by 100. So dividing by 100 means that you need to move the decimal point twice to the left. So it is 30.71. This is 37% of 83. All right. If they want, let me erase this. If they want, as in question 3 over here, 30% of what is $270? Mr. I know that of means multiply. So I'm going to send the 30% to the other side, but division. So it is 270 divided by 30%, which is 30 over 100. Keep change flip, 270 multiplied by 100 over 30. After simplifying, bye-bye to the 0 with the 0. Divided by 3 is 1, divided by 3 is 9. So 9 times 100 is 900. While in the next question here, which is question 4, they wanted the percentage. Oh, I remember Mr. Ahmed said you want the percentage, you must find a fraction multiplied by 100. So here, what is the fraction going to be? Of means times. You send it to the other side, the 900, you send it to the other side division. So it is 270 over 900. Oh, mister, we want the percentage. Don't forget to multiply by 100. After simplifying by to the 100, and the 900 becomes a 9. So it becomes a 30% of 900, which is actually the same as in question 3, but it's just, I just wanted to show you the steps. 50% of 90 is the same as 25% of what? Well, what happened to the percentage? Got divided by 2. So the number gets multiplied by 2. It's 180. Same thing over here. What happened to the 30 to become 90? Multiplied by 3. So dividing this by 3 gives you a 6. Increase 726 by 39%. You got two methods actually. Using the multiplier, which is going to be 726 multiplied by 1.39. Mister, I don't like this in paper 1. If it's in paper 2, then thank you. I'm going to find the answer easily using the calculator. But in paper 2, in paper 1, if I want to avoid multiplying 3 digits by 3 digits, you can just simply find 39% of 726. However, mister, just as we did in the question number 2, what is 39 multiplied by 726? And then you divide the answer by 100. So I'm going to do 726 multiplied by 39. Here is 54. Then it is going to become 1823. Then it's going to become 6365. Then you put the 0, 18, which is going to lead to a 7. Then 3 times 7 is 21. Add them up, gives you 4, 11, carry up the 1, 6 and 7 is 13, carry up the 1, 7 and 1 is going to give you 8, then 2. So, mister, it is 28314, but don't forget that you need to divide by 100, so it's going to be 283.14. So 283.14. Is that the answer? No, you just found the 39% of 726. You just need to add it to the what? To the 726 because they said increase. If it was decrease, then you would have minus this number from 726. But here it's increase, so I'm going to add. And the answer is going to be, here you've got the decimal places as they are, and here you've got 9, then 1009.14. This is for question 7. Just find 39% of 726 and then add it to 726. This is if it comes to you in paper 1. But in paper 2, just use the multiplier, 726 multiplied by 1.39. Thank you. 720, let me just erase this first. All right, here. In question 8, $720 increases by 70% and then decreases by 20%. Find the overall multiplier. Well, to find the multiplier, you need to find first the first multiplier, which is increased by 70%. It means 170% because we added to 100. So it's 170%, which is actually 1.7. This is the first multiplier. Then decreases by 20%, so it's 100% minus 20, which is 80%. But as a decimal is 0.8, this is the second multiplier. So to find the overall or the compound multiplier, we say 1.7, the first multiplier, multiplied by the second multiplier, which is 0.8. This is going to give you the compound multiplier or the overall multiplier. So 1.7 multiplied by 0.8, ignore the decimal points. 17 times 8 gives you here 56, which is, after that, 8 times 1 is 8, and 5 is 13. So 136, but I have 2 decimal places. So 1.36 is the compound multiplier. A city's population is 10,000 and grows 10,000 and grows by 3% each year for 5 years. So find the population after 5 years. Here is the calculation. The calculation is 10,000 multiplied by the multiplier. What is the multiplier? It grows, which means it increases 3%. So 1.03 is the multiplier. It is 103%, but divided by 100 is 1.03. Multiplying them by each other is going to give you after 1 year. Good. But Mr. I don't want after 1 year. They want it after 5 years. So you should do 10,000, which is the population right now, multiplied by 1.03 to the power of 5. Here is the calculation. You use your calculator for this. This question, if it comes to you, it's going to come using the calculator. You find the answer. If they request only the calculation, then you just leave it this way, because it might come to you in paper 1. If it comes in paper 1, this way, they will request only the calculation. So the calculation, stop here. Stop here. They want you to find the population after 5 years, and then they're going to bring it to you in paper 2, and you will use the calculator. Here is a scenario. A TV is now priced at $1,452 after a 10% increase. The question here, find the multiplier for the increase. Well, it is 110%. I added to 100 because it's an increase. But divide by 100, it gives you 1.10. This is the multiplier, or just 1.1. Where got the original price? Okay. If they want the new price, we multiply by the multiplier. Again, if they wanted the new price, then what do? Multiply by the multiplier. If they wanted the original price, like in this case, or the original value, you divide by the multiplier. So what are we supposed to do over here? You're supposed to do 1452 divided by what? The multiplier, which is 1.1. Using the calculator, you're going to find the answer. Here, rounding. You're requested to round this to the nearest hundredth. So where is the hundredth? Well, this is here, hundredths, ends with an S. Here, the tens, the ones, or to the nearest whole number. Here is tenth, hundredth, thousandth. They want to the nearest hundredth. So rounding it to the nearest hundredth over here, you must look at the digit that is after it, which is strong. 5 or more is strong. So it is strong digit, the digit after it. So the 9 becomes 10. Add to it 1 becomes 10. But carry, don't write 10 over here. No, it's 0 carry up the 1. This becomes 9. And then the rest of the digits stay the same. After it, what happens to it? Do I turn the 60 into a 0? No, it's a decimal place. So everything after the one that is circled, the one that is you're rounding to, everything after it turns into a 0, yes, unless it is a decimal place, it gets removed. So to the nearest hundredth is 305.90. And this 0 here is extremely important because it's in the hundredth place. This is what they want to see. Rounded to 1 decimal place. So let me erase this. Here is 1 decimal place. The digit after it is stronger, so the 8 becomes 9. Everything before it stays the same. Everything after it turns into a 0 unless they are decimal places, they get removed. So it's only 305.9. 2 significant figures. Oh, where is the first significant figure? Mr. Rahmat told us before that the first significant figure is the first non-zero. So can the first significant figure be a 0? No. Can the second significant figure be a 0? Yes. So here is the first significant figure. Here is the second significant figure. The second can be a 0, yes. The first, no, cannot be a 0. So here, this is the second significant figure. The digit after it is strong, then it gives it 1, so the 0 becomes 1. Everything before it stays the same. Everything after it turns into a zero, unless you're talking about decimal places, you remove them. Round to three significant figures. So here is the third significant figure. Digit after it is strong, so it becomes 6 instead of 5. Everything before it stays the same. Everything after it turns into 0, unless they are decimal places, they get removed. The last question over here is rounding to 5 significant figures. Here is the first, second, third, fourth, fifth significant figure. Oh, mister, it is the same as 2 decimal places. Exactly, it is the same as 2 decimal places. So look at the digit after it. The digit after it, well, 2 decimal places, which is the same as hundredth. So now it's just the same step exactly that we did in the first question, rounding it to the nearest hundredth, which is going to be the same answer as this, 305.90. So 5 significant figures turned out to be the same as rounding to the nearest hundredth. Here in the percentages question, not percentages, over here, this is a pie chart. They're telling you 40 years and older, own a car is 160 degrees. 40 years old, own a car is 300 degrees. And here is the frequency of those who are under 40 years old and those who are above 40 and older. And they're requesting find the total of those who own a car. Well, mister, I got here 2 parts for this question. Look at that. The first part over here, those who own a car and they are 40 years old and older, or under 40, doesn't matter, under 40 and own a car. How can I find it? Mr. Homa, the own a car is 300 degrees out of 360 degrees. Multiplied by how many are under 40? Under 40 is 378. All right, then this will give you the number of those who own a car and they are under 40. So I'm going to get my calculator and do this. 300 over 360 multiplied by 378 equals 315 exactly. So 315. All right, what about those who are 40 and older? 40 years and older, they are 160 degrees who own a car out of 360 degrees multiplied by 40 years and older, 270. They are 270 people using your calculator. Or actually here there is no need for the calculator, but if it's paper 2, and usually this comes in paper 2, if there are hard numbers or hard calculations, they don't waste your time on that. 160 over 360, then you multiply it by 270, gives you 120. So the total of those who own a car, whether they are under or above 40 years old, it's 315 plus 120, which is 435 people own a car. Here in this question, they want you to show this on the pie chart. Small cups, 6. Medium cups, 10. Large cups, 8. And they want you to show this on the pie chart. How can I do that? I need first this to be turned into degrees. Pie charts, I know that the total of it is 360 degrees. But I want only 6 cups. But 6 out of how many? These are 6 out of 6 and 10 is 16. 16 and 8 is 24. So 6 out of 24. Then you multiply by 360 degrees. Gives you 90 degrees. Medium cups, they are actually 10 over 24. But out of the 360 degrees, it is going to give you exactly 150 degrees. 8 cups, they're actually 8 out of 24. You multiply it by 360 degrees, which is going to give you 120 degrees. Then, how can I show them on the pie chart? Get your protractor. The first thing that you must do is to draw a radius. You must draw a radius to start with it. This is the first thing. You must draw a radius. After that, you get your protractor, and this is going to give you here the 90 degrees is over here. plotting this on your protractor and on the paper is going to help you draw the 90 degrees. So this is the first one. And right here, small. While the median is 150 degrees, then I'm going to get my protractor and do this. And I choose 150 degrees. It is over here. Here is the 150, which is this one, this side. With your ruler, you connect it. You connect this, but you can stop over here. With your ruler, you can find over here that this is going to be the medium, 150 degrees. And this is the 90 degrees. Then automatically the 120 degrees will just be drawn. All right? Before leaving the question, I need you to ask yourself always, once you use the protractor, does this look like a 150-degree angle? Yes, it's obtuse. Just in case you choose the wrong side of numbers on the protractor. Does this look like 120 degrees on the protractor as an obtuse angle? Yes, it looks correct. 9,000 people visited the stadium, corrected to the nearest 1,000. What are the minimum and maximum possible numbers of people? So here, they're telling you that 9,000 people visited the stadium. They wanted, this number is rounded correct to 1,000. They wanted the minimum and maximum possible numbers of people. So actually, this is about the lower and upper bounds. So writing this in the form of an inequality, you're going to find that it is rounded to the nearest thousand. So you add or subtract 500 to get the lower bound and the upper bound, which is half of 1,000. So inequality is as follows. X is greater than or equal to less than. It's always like this. So X is greater than or equal to what? Minusing 500 is going to give you 8,500. Plusing 500 is going to give you 9,500. So, mister, in the inequality, I always add and subtract the 500 and I write them? Yes. So, the lower bound here is what? You take it right away, copy-paste from the inequality. The upper bound is what? Well, the upper bound, you must ask yourself, the kind of data you are dealing with, is it discrete or continuous? What is the meaning, Mr. of discrete and continuous? Discrete, is it countable? Can you count them? Can they be written as a decimal? No, mister. So it's discrete. They cannot be written as a decimal, so this is discrete. Discrete data, for the upper bound, you take the one in the inequality minus one from it. So it is 9,499. Because it is discrete data. Discrete data cannot be written as decimals. So the largest possible number of people is 9,499. All right, what about here? The second example, I got the cost of a car is $9,000 to correct to one significant figure. One significant figure is actually the thousands. So it is thousands. Just like the first one, mister, everything is the same. Yes, everything is the same. It is X is greater than or equal to minus 500. It is 8,500. Add 500, it is 9,500. So the lower bound is going to be what? The minimum and maximum possible costs. The lower bound is going to be 8,500. Okay, mister, what about the upper bound? Well, the upper bound, you must ask yourself, is this discrete data? Discrete data means that they cannot be written as a decimal. Can you write money as a decimal? Oh, yes, mister, I definitely can. I can write like $8.5. I can write $8.95. Yes, this is actually continuous data, right? It's continuous. I can write it as a decimal. So if it is discrete, we agree the upper bound minus one. If it is not discrete, if it is continuous data, then you must keep the upper bound as it is. It is 9,500. You need to study this part. Many students get confused between the discrete data and the continuous data when dealing with the upper bound. The inequalities, they don't change. Inequality doesn't change, discrete or continuous. The lower bound doesn't change. discrete or continuous, it doesn't change. Upper bound changes. If it is discrete, -1 from it. If it is not discrete, it's continuous, which can be written as a decimal, keep it the same. It is 9,500. So the next one over here, the time spent is 7 hours, corrected to one significant figure. What are the lower and upper limits? Well, to write it as an inequality, x is greater than or equal to, less than or equal to. Here, corrected to one significant figure is, well, actually, there's a mistake over here. It was 70, to be honest. It's 70 hours. 70 hours correct to one significant figure. So this is the tens, right? The first significant figure is the tens. Again, not to get confused, it's supposed to be 70. I made a mistake. I wrote only 7. It is 70 hours. So here, it's the one significant figure is the tens. So I add or subtract 5, the tens. So the lower bound is what? -5, it is 65. The upper bound is what? It's, well, I'm going to write here, no equals. Here, it is less than 75. Well, so what is the lower bound? It is 65. What is the upper bound? Ask yourself. The upper bound, shall I take it copy paste from the inequality or a -1? Is this discrete data or continuous data? Can you write it as decimal? Yes, mister, I can write the hours as a decimal, 70 hours and a half, 9 hours, 0.6. So this is continuous data. I can write it as a decimal. You can write it as a decimal, continuous data. So just to take it, copy paste to the upper bound is 75. We do not -1. Remember this here. If you wanted the lower and upper bounds and it's rounded to the nearest 1,000, you minus or add 500. Nearest 100, you minus or add 50. Nearest 10, you minus or add 5. It is half of it. Half of the number that you're rounding to. You're rounding to the nearest tens, minus or half, minus or add 5. The nearest whole number, minus or add half. So the nearest tenth, minus or add 0.05. Make sure that you study this and that you know it very well, and so on. That's it. Thank you so much, everyone, and see you in another video.